Okay. Hello, everyone. Welcome to our session. So today we will talk about the Kubernetes as a service, the open source cloud on Arm64. So as we know, the Kubernetes is really famous all over the world, and especially in the open source community. First, we want to have a brief introduction. I'm Kevin Zhao. I'm the tech lead at Linaro LDCG. And also my colleague Xinliang Liu, he's the senior engineer on Linaro LDCG. So if you have any questions with the cloud infrastructure side, please feel free to contact us. Okay. So just first a brief introduction of the Linaro Datacenter and Cloud Group. So actually, we are focusing on the Arm-based server and infrastructure ecosystem development, and our mission is to eliminate the fragmentation and reduce the cost to accelerate the Arm server to the market. So our members can focus on the innovation and differentiate the value added. So actually now we are focusing on several parts. So first is the server architecture, and also we are covered the big data, the cloud infrastructure, and the HPC and the AI area. Besides, we have maintained Linaro Developer Cloud. We are using the open source technology to manage the Arm enterprise Arm-based powered system. So we are welcome the upstream developers and the upstream community to have the collaboration with us. So if you want the Arm-based resources, please feel free to have an application on our website. And here is the engineering workloads we are working on. So just a brief introduction of the Linaro Developer Cloud. So we are totally based on the infrastructure level on the OpenStack and Ceph. And also we are offering the Kubernetes as a service now. So now we are actually being certified by OpenStack and also by the CNCF. So our talk today will be three parts. First is a Linaro Developer Cloud infrastructure level introduction. And after that, we will talk the Kubernetes as a service realization on the OpenStack. And the last part is the Kubernetes and OpenStack integration. So now I will hand over to Xinliang.
Okay. Linaro and LDCG. Let's come to the first part. The first part is our Linaro Developer Cloud and infrastructure service introduction. This is our infrastructure service solution overview structure. As you can see, we use OpenStack to build the infra. Know our trades, and all the required trades are in the upstream. So in the left-hand side, the bottom are our Arm64 server. On top 10, running OpenStack and Ceph. We use Ceph for our storage solution, and OpenStack we use the latest stable version, and we will keep upgrading it. For now, we mainly provide a user the VM service. And in the right-hand side of this picture is the monitor and deployment tools. Okay, this is the overview structure of our infra service. This is our level solution. we mainly use three networks. See the orange network. It is the external network used by the network node to provide internet access. And the blue network is the control network used by each node for control API network flows. And the red network is its internal network used by the compute storage nodes for data and application network flows. This is our deployment solution. We use Cola container deployment method, which is cool and amazing. It packages each component into container images, which makes deployment easy and upgrade easy. It also supports online upgrade. And for the co-op imaging, we release OpenStack R, ST, and U version in our Linaro account Docker Hub. And we also and you can also try upstream and release color images for Arm64 for the master and the latest stable branch. And for that, we release L and N version. And for provision the bare metal machine, we also can develop a tool called Meter Provider. Okay, this is the deployment solution. Yeah. This is our monitor solution. We use Grafana, LBaas, and exporters. We have developed OpenStack exporters to collect OpenStack metrics for Kubernetes. This is a platform of our monitor solution. Next. Okay. Our cloud is compatible, and we got OpenStack Power certification from the upstream from the OpenStack community. Okay, now we talk about the Kubernetes service for now cloud. This is the Kubernetes service overview structure. In the middle, as you can see, we mainly use Magnum project to build Kubernetes service, which utilize to create infrastructure resources such as VM network and Octavia for the load balance service. In the left-hand side, there is a OpenStack cloud provider for Kubernetes to use infrastructure resources such as volume and load balance service. Okay, this is the overview structure of our Kubernetes service. this is the Magnum architecture. Inside the Magnum, there is a API service and a conductor. API service serves the API request from the user, and then the conductor uses heat to create required influx resources and set up the Kubernetes cluster. The Kubernetes cluster is running on Nova VM instance. Okay, now let's see how you use Kubernetes service. First, we need to create a template before we can create a Kubernetes cluster. We need to fill some parameters for the template, such as the prepare, container text level, and so on. Once the template is created, we can create a Kubernetes cluster. And also, at the cluster creation stage, we still can check some parameters, such as master count, node count, and so on. Okay, this is the Kubernetes creation. Next, I would like to welcome my colleague to give more details on how Kubernetes and OpenStack integration. Thank you, Kevin.
Okay. Thanks, Xinliang. So now I will talk about the first the Magnum creation process for the Kubernetes cluster. Yeah. So as we know, first the Magnum is served for the Kubernetes provisioner for this Kubernetes as a service. So if we want a multi-master node Kubernetes, we need to set up the load balancer, because the external access to either the external access to the API server or etcd, or the internal access from the Kubernetes to the Kubernetes master, they are all need HA proxy, or as we know, the load balancer to rotate it. Yeah. So as we see, the load balancer is very important. So because our solution are on top of OpenStack, so we are using OpenStack load balancer as a service we called Octavia to do these things. So the process is, first we can create the load balance. So it will the Octavia will connect the network from the load balance, and after that the Octavia will provision an Emperor. One Emperor is a virtual machine with the HA proxy installed, so it can be served as a load balancer and mount with the floating IP to offer the external network support. So after the creation, we need to configure the load balancer. And here we can see in the right picture, there is a generally unit for the load balancer. So each of so first we can see the data model here. So each load balancer have a listener, and it serves as for the one HTTP request. So we can see the listener 1 are working for the HTTP port 18. And also the listen 2 are working for the 443. So each listener are mount a pool, and which has been composed with different members. So in the beta unit, Octavia has Emperor virtual machine here, and one member inside the Emperor VM with HTTP 8 will join the pool 1, and the other one will join the pool 2. Oh, sorry, the other one at the VM2, HTTP 18 will join the pool 1. So we can see, so it has been connected with the Emperor 1, and each of the external access from the listener 1 will be rotated and HA proxied to the VM1 or VM2 at the port 18. Yeah. So after we got a general information about the load balancer model here, we can see it will create the listener for the API server, Kubernetes server and etcd, and then the load balancer pool create for the listener, and it is the members we see to the pool. Okay, so after the load balancer has been created, we are now kick off the process for the generally provision the cluster. So first is general information. We need to prepare the resources, set up the network, because we are on the infrastructure as a service level. We need to set up the private network for the cluster and set up the security group and also sign the TLS cert for the Kubernetes. So after that is the creation the balancer we have referred on the last slide. And then is the creation master. So the creation process is very simple. It will call the OpenStack Nova to provision the virtual machine. And after that, it will use the head container agent to doing what we want. Here we have defined, we are using the systemd containers. We are using the systemd to manage the containers. Here the containers are mainly for the Kubernetes components such as the API server or etcd. So each of the components has been launched here by the Kubernetes, by the systemd and Podman. So after that, we have doing the same things at the worker node to launch the kube proxy and also the kubelet. So, and then we can let the worker node join the master. So after that, we can have a Kubernetes cluster already. Okay, next is the overview for this cluster. We can see that there are generally three kinds of network. The green one is the container network, because each container inside the Kubernetes cluster needs to be connected with each other. So we can now we can support Calico and Shrino, yeah, for example. So the other one is a private network. So this one is for the cluster node internal traffic, because each of them are in the same private network, and the cluster nodes are based on this network, and it is the fundamental work for all the virtual machines that running the Kubernetes components. And the last one is the external network. So that one is for external access. So they are connected with the three different load balancer. We can see here in the red picture. In the red block, there are three load balancer. One is for the Kube API server. The other is for the etcd, and the last one is for the ingress. So the API server and the etcd are exposed to a load balancer for not only the external access from kubelet, but also not only the internal access from the kubelet via the private network, but also the external network access via the actually you can mount a floating IP to this load balancer, so that you can get access to your Kubernetes cluster on the internet. And also the last one is ingress load balancer. So this one is for if you want to running a pod applications inside the Kubernetes container. Yeah, maybe you want to deploy a network, a website here, so you can actually use the ingress to offer external network support. So we will cover the technical details next on the next session. Yeah. Okay. So what is the difference with Arm64? We can see we have actually integrate a lot of components and doing something and integrate and actually working on some upstream development. So generally our work are first a multi-architecture support for Kubernetes and Ceph, and also the Arm64 platform OpenStack, Ceph, and Kubernetes validation. Next is the production level Arm64 open source cloud upgrade and maintenance. because actually we are use our solution on the real production level system, that is Linaro Developer Cloud. And also we are keeping and maintaining the OpenStack upstream CI. And also we are actually running the Kubernetes conformance test generally to achieve the CNCF certified cloud. Okay. Here is a Magnum solution. Here is the generally next stage of the Magnum provision solution for Kubernetes, because here we know that we are actually doing use the Magnum process to create a Kubernetes cluster, and we see that it has been easy for just one API to provision the cluster, but we may meet a lot of problems because the legacy creation process is we need to do the totally creation process one step by step, and the time of the consuming is a little it will have a big time consuming first. And also Magnum has defined a lot of the scripts, so it is very hard for us to extend to multi-architecture or maintain the different version of Kubernetes. And the last one is, if we want a Kubernetes multi-master, we need to provision at least 3 virtual machines for the master node, and 2 load balancer for external access. So generally, those 5 VMs are not running your workloads. Yeah. So do you see that it may be a lot of the effort and a lot of the load pressure for us? Because if you want to run this on a private cloud, you need to pay external money for your application because the Kubernetes master control plane ticket. So due to this issues, we have actually turning to another method to realize our Kubernetes as a service. So we have just talking about this about the kube-in-kube solution. So first, we have defined the seed cluster. It is a VM based. We can create a seed cluster just as we done in the legacy process in the service tenant. And also, besides, the next is after creation, the Magnum will get the kubeconfig files from the seed cluster. And also, if you want a custom cluster, all the custom clusters components here will be launched at the master node master cluster's worker node. Yeah, on the seed cluster's worker node. So all the Kubernetes components in the custom cluster will be served as a container component and managed by the seed cluster. So that will be actually reduce our control plane consumptions first, and also we will let Kubernetes to manage all the custom clusters control plane containers. So we can leverage the traditionally Kubernetes deployment tools such as kubeadm to realize this. So we don't need to maintain a lot of descriptions. Yeah. So here is our it's a training for this Magnum provision. So and we are working on it. Okay. So next we can just a brief introduction about Kubernetes and the OpenStack integration. So because when we have our Kubernetes cluster, we may need to be want to access the infrastructure level for access the more storage, more network support. So it is very essential to have a lot of the controller here running at the OpenStack, running at Kubernetes side to talk with the OpenStack to get the results and doing the control plane communications with each other. So here is a generally four components we call the controller that is running on the Kubernetes cluster. So first is the Cloud Controller Manager. Yeah, so it is a key point here, and it is very important. So it has been separated for 4 controllers. So the Cloud Node controller serves for the Cloud Node life cycle management, and the Road controller serves for the network connections for the different node, and also the service controller. We are leveraging this to realize the network support, and the last one is the PVC controller for the service support. Okay. So if you want a network service integration, here, yeah, we may need to have a diff to see the load balancer as a service in OpenStack. We call it Octavia. So Octavia is a very important component here, and it is an Emperor to offer the driver. One Emperor will be served for 1 VM with HA proxy plus KPLAB installed. So if you want a load balancer from external, so you need to tell the OpenStack to provision to launch a load balancer for you. So you may curious about where you are integrate a lot of Kubernetes components. So not only the Magnum, the Heat, the Octavia. So these Kubernetes can do these things. Yeah, actually not, because as we know, the Kubernetes is a orchestration platform, and OpenStack serves as the infrastructure as a service. So if you're running the Kubernetes at the AWS, for example, or the Azure, so you also need to tell the AWS to provision a load balancer for you if you want the external network support. Okay, so the next we can see the detail about how to realize the network integration service. If you want to deploy a container and running your network and make your network external size, how could you do? So here, first, we can see it is an ingress. So ingress is a concept that allows the external user and client applications to access the HTTP service. And we also need to know the service. Service concept is an abstract way to expose an application running on a site or pod as a network service. And then the controller, Kubernetes run a group of controllers, take care of the routine task, and also you can to ensure the desired state of the cluster match the observed state. So actually all our logical are land into controller. So we can see first there is a pod 1 run T server, pod 2 run T server. They are exposed by T service, and pod 3, pod 4 exposed by coffee service. Now we can have an ingress object. So the ingress object defines the path T via the T service, and pass all coffee, the backend is the coffee service. So after the ingress object has been created, then the Octavia ingress controller that is running in the Kubernetes will be watch this object change and tell the OpenStack Octavia service to create an Emperor backend for this ingress. It will launch the Emperor, configure the HA proxy, and configure the HA proxy rules. So after that, you will have external access from the internet. So yeah, it is a general information for if you're running an application in the Kubernetes cluster, how would you do? Okay. Okay. After all our work with OpenStack and the CNCF, now we have got the CNCF certified cloud. You can actually see our brand and the logo and also the information here on the CNCF landscape. All right. Okay, the next slide. Yeah, we're finished. Thank you for listening to our session. And if you have the interest on the CI/CD or upstream development, and if you want to the resources, yeah, we welcome your application at our website. Thank you.